Hey guys, Coder here. So today I'm going to be talking about my language and the features that I was talking about. I'm going to basically describe a lot of the different parts of my language, and I'm also going to update on the fact that I have finished the actual interpreter. So it is written in the shadow language, which currently converts into JavaScript. There is a test file which gets this file and actually interprets it, and it gives a build, right? And there's actually a bunch of parts to it. So this is for the building, and this is for the interpretation. And then it actually gets this file. Obviously the comments are not built, they're removed, and it gives us the build output. It gives us what the interpreter was able to find. So like our function add AB removes that comment obviously and gives us the function, and the other function and all the other functions, basically the whole thing. But I'm going to actually be talking about the features of my language that obviously are not implemented right now. This is only the interpreter. It can read what I'm writing, but it can't convert it into valid machine code yet, which is the part that I'm going to be working on for now. Like, I'm going to start now. I finished this on Friday, the interpreter. This morning I was modifying it, fixing a few things here and there, and writing this documentation file just so I can talk about it. So here's your normal function declaration. In languages like JavaScript, you would write function AB and then return A plus B, but in my language you write it in this form. Obviously there are obvious changes within my language. If you want to have a local variable, you either use var or let or something else, like let A is equal to 10, let B is equal to 15, A plus B, assuming that there are, I forgot this, assuming that there are no arguments. And then you might write the same function in here. A is equal to 10, B is equal to 15. Obviously in my language you don't need to include this. These variables are automatically local, and if you want them to be global, you use this prefix. That's the global namespace. That's that. And then arguments are optional, so if there's no arguments you can just create an instruction instead. This will give 30. More than one instruction requires a block, obviously, and global and system global. So those are the different namespaces of my language. Then there's the main function declaration, and then there's a code here. And from now there will be a lot of these, because in my language you can't just have a block by itself. If I have a block by itself and I try to actually interpret that, it's going to suddenly tell me that it was able to read all the way up to the main function. It was able to read all the way up to this main function, which is the empty main function. And then it ran into this block, and it didn't know what it was, which is this block right here. So that's why from now I will be prefixing every code block with this in order for it to interpret it properly. So now we actually have the full build and no complaints. The whole thing is here. No comments. So there's the memory addresses, obviously, A, global A, system A. They're all in different namespace and they don't conflict. Address operations, your standard stuff. but this is different from most languages because they use this for the XOR operation, or however you're supposed to say it. This is assignment, add, subtract, all your standard stuff, and obviously it's standard as well. Lookup, call, stacked operations, nothing interesting here. Standard expressions. So a lot of these will be missing because I'm going to create a basic machine code port, and then I'm going to play around with it to see what implementation I will have for expressions in the end. I still don't know for sure. But these are the values at the moment: expression, immediate, hexadecimal, local address, global address, system global address, array, text, and scope text, which is usually called string. And these will not actually be implemented yet in the same way that they are in things like I don't even know exactly how I'm going to implement these yet in machine code, so I'll have to see that. And then there's the connectors, first port support. So these are the ones that I'm going to support in the first port for the machine code language, and then I won't support these yet. And then these are the examples for using all the different values and connectors. As you can see, they are all compiled main interpreter correctly. And you probably have noticed by now that my actual compiler for an interpreter for this will first be created in, you could say JavaScript, but it's not JavaScript because it is actually created in the shadow language, as you can see here. This is my current highest form of the shadow language, which is different from this here. This one is supposed to be more advanced, but you will have some features missing because it's not porting into JavaScript. You will have some features missing that are in here. And actually the first version that I'm going to create, I'm going to call it Shadow Basic. And it's supposed to actually not have floating point unit operations. I don't know exactly how that's going to work, but I am going to create two versions of my language. I want to create two versions of my language that will port into machine code. One of them I'll call the Shadow High language, or the normal Shadow language. And then this one that I'm working on now, this will be the Shadow Basic. There will be two modes of my language that I still am drafting out, but that's kind of the plan. So besides that, there's all the directives: structure declaration, dynamic structure declaration, the if equivalent, else if equivalent, while loop equivalent. Oh, I forgot. Let's just make sure that compiles correctly. Well, interprets, I mean. And where is our directives? Direct. And then there's obviously the while loop equivalent, continue, break, return, and void return. So in JavaScript you would say return with a semicolon, but in here you just, semicolon aren't really, like, you can use them. A is equal to 1, B is equal to 2. You can use semicolons because I have actually added a reader for semicolons. As you can see, there's no complaints, and when you look here, A equals 1, B equals 2. So semicolons are read correctly as the end of an instruction. I don't know exactly, like, I haven't fully tested it for every instruction how it will work out, but I think it will work fine if you just semicolon every end of the line. I'm not going to try that now because I don't want to bother fixing any errors. And then there's a structure declaration. You know, you create a structure called ship in the global namespace with X and Y coordinates, and then you can use it with the new syntax. You create the new ship into this local variable, as type ship, or you can just declare the local variable as this structure, and then you can create a ship in this local variable with specific coordinates, and you can create structures in an expression. So ship is equal to global structure ship, and then colon and the creation thing. You do not need to define the type of ship when using this because carryover feature. So then this will automatically be of type ship because this will carry over into the actual address. The following code is valid. Automatically detects ship to be of type ship. So that's just demonstrating that. The way to access, so that's how you access properties in my language at the moment. You can also use I haven't actually implemented it yet, but okay, what's that? For some reason it doesn't actually seem to be. Oh wait, never mind. Oh, here it is. There it is. So I haven't exactly figured out what I'm gonna do with the dot, and I'm definitely thinking about having different modes of my language with different interpreter ways to interpret the code based on the person. But of course now that's not something that I'm worried about. For now, this is how you access the properties of a structure, and structures have an alternate namespace to normal addresses. So yeah, this will not conflict with this. This is a global address, this is a global structure, and they both are in a different namespace, so they will not conflict. And then there's the new features. So dynamic structures, you create a structure and you don't define any values in it, or you can define if you want. But you can actually access or define parts of that structure which were not initially defined. That's called a dynamic structure. So you create it, and then you can do this, and then the compiler will automatically detect and add these undeclared properties to the structure. Essence of dynamic structures. Yeah, who cares? So functions can now return a type. This is the type return, colon, and this is the actual address of the function, and it can now return a ship, and anything that uses that function will now be known to the program to be of type ship. You can now define structure methods. So if you create a ship structure, you can now create a method for that structure. Just paste that. That's pretty self-explanatory. Methods now automatically return the object itself at the end, so you can now stack any methods without needing to worry about making sure they return themselves. Again, that's pretty self-explanatory. Not really going to explain. And again, this self-explanatory. And of course, yeah, that doesn't really matter. Methods can have a type, so that's pretty obvious. It's not too difficult to understand. You basically call that, and it'll inherit this structure type, and you can now use it with the properties here. Namespaces. So you can now use namespaces on any address to specify an alternate space for naming other than local, global, or system global, which are the standard namespaces. So you create a namespace and you use it pretty much anywhere you want inside a function. In this case, it's just a block of code. You can create structures within a namespace. Structures will be in a different namespace to the addresses namespace as demonstrated here. You know, the ship will be assigned an instance of the ship structure, which are both within the namespace, but they do not conflict with each other because one is a structure and the other is an address. memory address. And then we have the file-wide namespaces, just like that. And then we have multiple return values. It's a new feature as well. You will now be able to return multiple values within any function. It's still experimental. There is no implementation yet, but here is the draft. You can declare any function / method with multiple return values. You can then assign the result to multiple addresses simultaneously. Obviously there's a semicolon at the beginning, which is important. So you get the coordinates, it gives you this, then you assign it to 2 addresses. Mostly experimental, yeah, doesn't really matter. And then there's the assembly only features, which is pretty simple and obvious. So there's a assembly line, and then there's an assembly block. And again, they all get interpreted as demonstrated here. This code is not checked for validity, so whatever you put in here, if there's an error, Phasm, in this case, Phasm will actually complain as opposed to the interpreter here. However, what is taken into account is any nesting. As you can see here, this would usually end this. However, it will not, because these are actually read, and if they are inside comments, then they will not be read. This is a comment in assembly / Phasm. So if I actually try to, let me just clear that first and interpret that, as you can see here, these are kept inside and they're taken into account. Okay, nest in, nest out, and then finally when this one is put forth, it will actually end the assembly interpretation. And again, you use the prefix. You have to use the semicolon in the beginning if you don't want the program to have any errors. But if you use it as a first instruction, then you don't need to. You could, as shown here. It will still interpret it correctly, but you don't have to. There we go, and it's perfectly fine. Comments are obviously removed. There's no comments here. That's the other part. So it does read assembly comments and remove them. And that is pretty much it. So that's kind of the current draft E documentation for my language, and it's obviously not the most expansive one. It's as basic as possible, just showing some of the features and, well, teaching you a little about the language that I'm working on. So thanks for watching. Comment, like, and subscribe, and peace.